Okay, so we'll start the second session for the day. The session is about semantic standardization, and it will last until 1:30 when finally we will have lunch. The session is chaired by Gyomai, from our colleague from the OECD. And, well, I'll leave it to you, Gyuri, then.
All right. Thanks, Luca. Hi, everyone. So let's start into the second session of the day. So it's about semantic standardization. I think there is already some tension in the title, because with semantic standardization we are usually going for a very palpable trade-off between two goals. We would like to call the same things the same way and compress things into let's say a limited space of reused and connected concepts. But at the same time, as kind of the semantic word suggests, we are also trying to maintain semantic precision and richness in the description of the world that we measure with statistics. And also we want to maintain flexibility to adapt to various contexts in which our data is living. So yes, the presentations that you will see today will either focus on the standardization part or just go into questions around this maintaining of semantic richness while still trying to call the same things the same way. And so the first two presentations will be about the efforts of moving forward the standardization. The standard itself is just providing a vehicle, but then there are lots of efforts outside the information model that have to be put in by the statistical community to harmonize concepts and classifications, the SWG to provide guidelines, and then to maintain artifacts centrally. And then, of course, the global DSD initiatives all point into this standardization effort. So, as I said, the first two presentations will move more in this direction. But then, in the second half of the session, we will see two presentations pointing roughly in the same direction, and they are kind of highlighting the need to preserve some semantic richness and the impossibility to go down fully 100% on the standardization road. So the first presenter will be Abdullah. He will give a talk on SDMX-based classifications. Abdullah is a statistician at the United Nations Statistics Division. He has designed and developed many statistical information systems, and for the last 12 years has focused on SDMX and capacity development with national statistics offices, as well as data exchange and dissemination of sustainable development goals indicators. Abdullah, the floor is yours.
Thank you, Yuri. Good morning. So, in this presentation, we'll talk about SDMX classifications. So, here's the situation at this time. It's 2024, and we have a total of 26 cross-domain code lists at the global registry. That's not a lot. I believe that this is a complete list of international classifications at the global registry. I might have forgotten one or two, but this is the general idea. ISIC, NACE, ISCO are the major standards covered. Then the COFOC, COICOP, COPNICOP, all those related to macroeconomic statistics with the exception of ISCO. And then, of course, we have ISO 3166 M49, which is a reference area code list. We have a code list for the degree of urbanization. The remaining code list, that's not, obviously, I mean, as you can see, it's not 26, but the remaining code list, they're not official international standards for the most part. I mean, it's great to have them, but these are the classifications we have. And as you can see, there are a lot of classifications that are not included in here. As you can see, many major international classifications are not available. When they are available, usually they only have the most recent version, which is the case with ISIC and ISCO as well, I believe. Mappings between these different classifications, they're usually not available. I don't believe we have mappings at the global registry. So, what do you do when an international classification is not available and you're establishing SDMX? Well, no, doesn't matter whether or not it's SDMX based. What do you do? Well, you have to create your own code list. And hopefully it will follow the classifications closely. There are a lot of problems with it. There is the link to the classification custodian is often non-existent, or if it's there, it's a weak one. There is no agreement on maintenance. These code lists are more difficult to reuse, and interoperability is compromised. There are some international classifications that are not published as cross-domain code lists, but do exist as part of global DSDs. Why not yet? Why are they not yet available as part of code lists? Well, the reasons can vary, but that's the current situation. So these issues, they came to the fore in the last couple of years, and in February of this year, the SDMX sponsors authorized the SDMX classifications task team, which is mandated to publish international classifications at the SDMX global registry, eventually covering all international classifications. That's the plan. What we strive to achieve is to have all SDMX classifications available at the SDMX global registry, which should really help improve the interoperability of our data, all of our data. So this is what we're trying to achieve. We want to establish the procedures for maintenance of international classifications. And I don't know if it sounds easy to you. In reality, it's not particularly easy. We need to establish communication protocols. We need to establish exchange formats, because we can't expect custodians of classifications to give us SDMX. But then, what can we expect from them? We need to establish the link to other standards, in particular semantic web, in particular SCOS and XCOS. And we'll get to the complexity a little bit later. And so once all these have been established, the international classification should be created as SDMX code lists and published at the global registry. What are the challenges? The challenge is it's a job that someone has to do, and we all have very limited resources, as you know. And in this case, it's a typical reporting and collector situation. We want to get the cooperation and engagement of the custodians of international classifications. Without their cooperation and engagement, we can't hope to have the classifications published. So what is the trick here? The trick here is that we need to establish maintenance protocols, maintenance agreements that minimize their reporting burden while maximizing, without compromising the quality takes two to tango. There is an effort on both sides. On our side, I don't think we'll find the resources to maintain all the classifications by ourselves. It's not our role anyway. But on the reporters' side, if we ask them too much, we will not get good response rates, if any. We can't ask the classification custodians to give us SDMX unless they are willing to provide it, which most of them will not. We can't ask them to give us XCOS. What can we ask them? Most probably Excel. But then if you go into that direction, then somebody, we really need to develop clear protocols and clear agreements, because somebody has the responsibility for converting those Excel spreadsheets into proper code lists. Somebody needs to update them when things change. Somebody needs to maintain the integrity. All of these details need to be agreed. And different approaches, different standards need to be reconciled so that we ensure that the classifications are updated when they are published at the global registry. They are maintained according to schedule, and they do not lag behind. So what we're using as a test case is reference area, which is not exactly a classification, but you can consider it a statistical classification. So we already have a cross-domain reference area code list, but it does need to be improved. We would definitely want to make use of the SDMX 3.0 code list inheritance. And this is what it gives us. At this time, the cross-domain area code list is a bit of a mess. It includes ISO 3166 Alpha 2. It also includes M49 codes, each in its separate sort of tree. But they need to be cleaned up, especially M49, which is rather complex, which has, we need to look at the currently inactive codes. We need to develop procedures for marking inactive codes. But eventually, the idea is to have separate code lists for M49 for ISO 3166, and then have a cross-domain reference area code list that merges them. So at this time, you have access to the individual code list or the cross-domain code list. And this is what we're trying to pilot. The procedures, the formats, the versioning, exactly what the minimum that can go, that goes into the maintenance, the code list, and the desirable features that need to go, that we would like to see there. How we retag codes, which is not easy at all in the case of cross-domain code lists. We do have the guidelines for management, of course, but I think that will need to be, to be careful when we work with specific classifications. At one point, the classification somewhere is maintained manually. So what should be the exchange format that minimizes the manual effort? What is the relationship of this to XCOS and so on? And that's it. We've just started this year. We are working. We will see the first results in the next few months, and hopefully we'll be able to report some progress next year. And eventually, I think that it's pretty urgent and it's pretty high priority to have all international classifications published at the global registry. Thank you.
Thank you, Abdullah. I think we have time to take a few questions from the floor. This is Stratos and Matthias. Yeah.
Thank you, Abdullah. I just wanted for information to let you know what we have been doing at the BIS, and also have a question about what you were proposing about the reference area. So at the BIS, we are facing pretty much the same problem, I think, as most organizations. We receive data sets from different organizations, different country codes. We had already in our data sets maybe 6 or 7 different standards for reference area. And of course, we use this DMX to do that. So we try to maintain all the different code lists. And the hardest part, to be honest, is the manual updating of, for example, the ISO codes. We have the M49 codes. We have from the World Bank, from the OECD. But what we are doing is that we have one blessed code list that we think that this is what we like internally, which is like an extension of the ISO, and then map everything else to that. So the idea is that internally we have one set of codes, and this is also part of what we're doing in our ingestion pipeline. When we integrate data, we try to map everything to those code lists. So at the end, the integrated data will all follow the same coding scheme. But from the question is, you were talking about this cross-domain code list. Is this something like that, like your internal code, or is it trying to get all the different codes into one commonly agreed, which is, with a big question mark probably?
Yeah, I mean, when SDMX started the cross-domain reference area code list, when it did appear, I think it immediately started using ISO 3166 Alpha 2 codes, right? But before that, like if you look at 15 years ago, 12, 13 years ago, a lot of people were also using ISO 3166 Alpha 3. So then anyway, the cross-domain code list was published, ISO 3166 Alpha 2, but the M49 standard, which is maintained by the UN, was not there. And it's an important one, it's very widely used, and unlike ISO 3166, M49 was created for statistical purposes. So around 2019, I think, the cross-domain code list included M49. So now it has both ISO 3166 and M49, and it's a bit of a mess, because M49 is a complex standard. It includes the official codes, it includes the extended codes. People need both. But to combine the whole thing in one code list, it does make it a little bit messy. So what we want to have ultimately is a clean M49 geographical hierarchy, clean ISO 3166 code list, and then a cross-domain code list that will inherit from both of these and will add the extended codes and political regions and others, right? So we're using it as a test case to establish procedures that minimize the manual effort. That's our goal, because if the additional effort required from the classification custodians is anything but marginal, it will be difficult to get their cooperation. We want to reuse as much as possible what they have. We want to make as easy as possible for them to report their classifications to us.
Thanks. I think we would be happy to share whatever we have, if
sure.
it helps.
Thank you.
Yep.
Thank you. Appreciate it.
Thank you. Yeah, that sounds like a very, recognizable problem, not just internationally, also internally. I think we developed the classification database, central classification database, and after 2 or 3 years, there were, I don't know, maybe 17 classifications in it. But in terms of, and on the other side, you can have examples where you have hundreds of classifications in it, but then you have 39 versions of sex classification and stuff like that. So, but one thing that maybe helps is do you understand or who would be the users of global registry? So, is there a kind of user community that would help you or directly custodians to persuade them to put more resources into this?
Well, if we're talking about users of the global registry, we hope that you will be a user of the global registry. When these classifications are available, we hope that organizations setting up their dissemination, they could reuse these code lists. And I think that they would be strongly encouraged to reuse them, even if they don't use SDMX, because in this case, the carrier is not important. What's important is the substance, right? How can we persuade the custodians to have them published at the code lists? Well, we want to, that's why we want to pilot it, we want to test it, and then we can approach it. I think there is definitely a plus for having classifications at the global registry. I mean, I can tell you, for example, that we don't have, I mean, the official M49 is published at the UNSD website. It doesn't have an API. We have received many, many questions, many queries for M49 at an API. We send them to the global registry. But then we have the issues because the actual cross-domain code list, it has a lot of things in addition to the official M49. So that was one of the reasons we are looking at it, to have it really clean. And then go on from there. I mean, the more profile this initiative has, the more profile the global registry have, obviously the more incentive for the custodians of the classifications to have their code list published there.
One more question from Edgardo.
Thank you. First of all, a comment regarding Matthias' point on who uses the global registry. I think that the SGDS should have an effect of making more people using the global registry, because it will be easy to discover things that are global on the fly. So I think that this work, this effort on having the classifications in order is quite timely. And another comment, and just because I'm afraid of forgetting it before the next meeting of the working group, there's an additional problem with the M49 and ISO classification that has to do with the different official names that different organizations give to certain countries and territories. And I don't have any solution to propose, but we're going to have to think of that.
It shouldn't be a problem, because yes, different organizations give different names. In that case, I would say that they need obviously to override the code list. Yeah. Hopefully they can inherit and override the code with the name that they use. Yeah. We will use the official names.
That's my point. I think that we have to suggest a way of doing that. But for example, Palestine has a different name for each agency. Yeah. And there are other examples in the world.
Yes.
There are few.
Let's not go there.
But if we don't observe that, our lawyers kill us.
Yeah. Well, again, we have to abide by the decisions of the General Assembly, and which is what we do. We publish the territories with the names as authorized by the General Assembly. But again, yes, we are aware that various agencies, even UN agencies, they use different names for theirs. But, well, you can take it and override it.
That's the UN family. Okay. Like any family.
Okay. Thank you, Abdullah. Thank you. So now I'm changing my hats. Changing my hats, and I'm stepping in the role of presenter. So the next presentation is kind of a result. Sorry, I should introduce myself. So my name is Gyomai. I'm from the OECD, but I'm presenting a work on behalf of the Unit of Measure task group that was a task group under the SDMX SWG, and was tasked to work on guidelines for modeling and harmonization units of measures, but also to try to come up with code lists and code list templates within this domain. And of course, as you will see, it's not just strictly speaking about units of measures, but it's units of measures and neighboring concepts that quite often go together with units of measures that we kind of put into our scope. So the context, the work has been initiated by the SWG, but it has been preceded by plenty of discussions that we had in various previous expert meetings and global DSD exercises. So the guidelines could be very brief, because one of the conclusions that we had in the discussions was really to align with the established scientific best practices and using ISO standards for units of measure application in scientific disciplines, and kind of use their companion method of deriving units of measures and establishing units of measures from a limited set of initial core units of measures through the use of dimensional analysis. And this is what the guidelines will propose. But while analyzing the wealth of data that we have in social economic statistics, we have seen that the standards and the current practices developed in the scientific field are not always complete enough to cover all the cases or give explicit guidelines for some of the statistics we produce in the socioeconomic field. So the guidelines will primarily focus on these areas where the standards have a blind spot. And then also there is another element that we try to work into the guidelines. It's the fact that we work with data warehouses, especially in the SDMX community. We build cubes and multidimensional data model, not simple flat list of indicator sets, at least in most of the cases. And so this is the other kind of value added that the guidelines would like to propose. And sorry, just if I can go back. No, I cannot. So I will just say one more word. With dimensional analysis, of course, it gives a nice tight system to develop further units of measures. We have seen that in the blind spots where we operate, sometimes it's not obvious how to apply dimensional analysis. So we asked ourselves the question of what dimensional analysis brings and what it does in the scientific world. And what we believe are the strongest points is that whenever we assign units of measures through dimensional analysis, we are marking the comparability and computation scopes of our newly produced data. So what we do is we tell that this data with this unit of measure is comparable with a similar, with data which carries the same unit of measure. And that's a very strong part of let's say, as a driving principle. We always ask ourselves this question, okay, what do we want to convey in a very brief manner about the computation scopes and comparability of the data when we propose principles or methods or clear-cut recommendations with units of measure assignment. So in the socioeconomic statistics, we have seen kind of two new elements. One is the measuring of monetary value, which is kind of not there in the SI and CGS systems. And so this is pretty straightforward to extend our workings with monetary value. There is a little bit of nuance with the fact that there are all sorts of currencies and all sorts of ways of adjusting for inflation and converting between the different currency areas. But even with that complexity, it's a relatively straightforward area. The one that we found a little bit complicated and where we spent a lot of time is measuring and counting the populations or sets of discrete things, where even in the science world, there is a lot of debate and discussion these days on how we should go about. There is already the mole that you might be familiar from your chemistry classes, but there is always a confusion whether the mole is just a large number and a unit multiplier, or whether it's actually the subatomic particle, which is the unit of measure there, and the Avogadro number, that very large number that multiplies it, is just a unit multiplier. So having looked at all our statistics, it really pops out that we need something to measure discrete, sets of discrete quantities. And here the guidelines will really propose a utilitarian approach, and we go back to this value in defining the computation and comparability scope by assigning units of measure. And in that respect, we are saying that really what we would like to do is a slight deviation from the practice in what we observe in science. And rather than using the mole, which is a very generic way of measuring elements, the number of elements in a set, we are saying that it's important, and it's often important, to be very specific in describing the items that have been counted. So if I was to give advice to physicists and chemists, I would recommend them that instead of moles, to use particles or atoms or protons or molecules, whichever in their specific context of measurement matters. So the other item that we pondered a lot and we based our guidance on this was rethinking the very coarse meta model of the units of measure existing standards of this is my measured quantity and then a number, and this, next to it the unit of measure, which is kind of my measured quantity is appearing as a multiple of the unit of measure. So that's pretty much the meta model. But then what we see is that quite often both the measure or the measured quantity and the unit of measure in our world is made up of many different dimensions and attributes. So we gave a little bit of guidance in that respect. But also we have run into one, probably the most controversial area that probably will lead to many discussions, is the way to handle cases where we divide two quantities that share the same unit of measure. So the example that I have here on the screen is debt to GDP ratio. So in a way, the resulting number of, let's say, 0.82 can be represented in two ways in a data warehouse. We can say that we have measured debt as a percentage of GDP, and we just have the number 0.84 and write around it the measure and the unit of measure. Or we can say that, yeah, we stick to the literal mathematical operation that we did to obtain this ratio, and then we represent it as debt to GDP ratio with a unitless number, or which is a unitless number, so we don't know really what to put in the unit of measure. So we can, yeah. Here, I think it's the guidance that comes from our proposal is really not so much what to put in the unit of measure here, but which approach to take if we can make a choice. And we really would like to promote the usage of change of unit of measure, at least in the, let's say, in compact, large, nicely structured data models, and maybe reserve the other approach in compendium style data sets or data sets where we need to have or we have more sparsity and less compactness. Okay. I will not go into further detail, but I'm happy to discuss the topic if you have questions around that. So, and the other recommendation is really just to break up the units of measures into multiple dimensions and attributes whenever it makes sense. To limit the proliferation of a large number of combinations of currencies and price bases and base years and unit multipliers. So I created the last slide. I won't go into all the recommendations, but I tried to pull out from the document most of the clear-cut recommendations. There will be many other recommendations in the document that you can read between the lines, or kind of guidance on how to apply coding patterns or how to interpret the principles in certain contexts. Luca promised me that the background document will be available on the expert workshop website. And of course, we are moving forward. So, in moving forward with these proposed guidelines, we feel that we are kind of ready to propose this to the immediate next audience, and that is the statistical working group, which commissioned the work. So we will have a first wave of comments and feedbacks that we expect, and we hope to be able to work it into the guidelines text relatively quickly, so that before the end of the year, we can go and have a broader consultation on the guidelines, and seek Secretariat approval to publish these guidelines. And finally, we aim to, at the moment, what we are putting forward is really just the text of the guidelines. But what we aim at is to also provide SDMX artifacts that go along with the guidelines. So for many of the concepts that we worked out in the guidelines and the code list for unit of measure itself, we are proposing partial code lists or code list components in the SDMX 3.0 sense, and then some templates and the examples on how to extend in certain directions the code list where it doesn't seem practical to cater for all the variations that might come from, let's say, derived units of measures or measures that come from the change of unit of measure approach with commensurable quantities. Let me just briefly check the time. I think I managed to stay within my allotted time, so I'm now ready to take a few questions. Luca?
Just a bit, I wonder, it wasn't clear to me if you have already, because in the macroeconomic statistics DSDs, we have this, we use the CL unit, which is, say, a non-official code list, but pseudo-standard because it's been used now by all the global DSDs. And it was, the codes there were built with some logic sometimes, which was not always applied consistently. But did you do, let's say, a check already of that code list against these guidelines? And so do you have an idea of the delta between that code list and these guidelines? Because this would be, you were mentioning that the package will contain code lists and concepts. To be honest, this comparison with this pseudo-standard code list that exists would be very useful in that context.
Yeah, it's a very interesting question. We did the analysis, and actually it was partly the driver of our work, because we felt that some of the practices that are in, let's say, the National Accounts Global DSD Unit of Measure code list are not very clear-cut, and they only work in the context, they only work in an exchange context, and only work in the context of the National Accounts Global DSD, or maybe for the macroeconomic statistics context. And in an exchange context, we can kind of get away more easily with design quirks. But I mean, a couple of examples of where we felt that there was too much packing into the CL unit code list of the global DSDs. For example, there is a long list of currencies that are embedded into the unit of measure code list, which we believe have a place there. But one thing that also snuck into this unit of measure code list is kind of groups of currencies, like, I don't know, currencies of the European Union, which they don't make any sense in a unit of measure context. They come from the currency code list, which kind of lives its own life, and they come from there because currencies are used for two things. They are used for marking the monetary value and hence the unit of measure, so let's say the reported currency and the measurement currency. But they also can mark a denomination currency of an instrument. So you can have instruments that have an original denominations, but they have been represented in another currency, which is the unit of measure. And for all those cases, all these, let's say, currency groups make sense. So as a denomination currency, you could group things like I express the US dollar value of all the European Union currencies denominated, I don't know, some monetary asset. So these are, for example, things that we would have to kind of remove from the unit of measure because they are misleading and they have nothing to do with the unit of measure use case. There are also some transformations and things where let's say, to keep the cube and the data model just one dimension less, there are very awkward transformations that snuck into the unit of measure description. I mean, we have the GDP per capita case, which should be just GDP per person, US dollar per person as a unit of measure, but we have some sort of weird combination of a transformation that makes reference to the population, which acts as a GDP kind of scalar. It doesn't work as a unit of measure. All that information should be combined with the descriptor of the measured quantity rather than the reference quantity with which the measurement was made. And there are examples like that for which we really felt that we need some guiding principles and more kind of ways of structuring our approach rather than going immediately and building a unit of measure code list. So, and I think because of that, the guidelines may not be immediately easily approachable because there is a lot of this deliberation of how we get to a certain recommendation and conclusion, but I think it will be an interesting read. I hope so. Yeah. Yeah, it works.
I was thinking the decomposition of a complex unit of measure obviously leads to the need of having the unit of measure model as a dimension, because you will have to disambiguate among the different flavors of the same measure. My question is whether you have analyzed the new multi-measure possibilities of modeling where you may have different measures holding different unit of measures, but not possible to disambiguate because there will be no measure dimension, let's say, in the model.
Yeah. That's a very interesting question. I have to say we haven't done that exercise, so it's probably something that we have to scan the document and the guidelines with that eye. I think it will. I mean, our original recommendation says that we are pretty much agnostic whether the unit of measure is modeled as an attribute or as a dimension. It really. I mean, we should just pick the role of the components as we see fit in the data model. But ultimately, if there is a need for, I don't know, for editorial precision or for whatever end use to have an additional attribute that more precisely explains the unit of measure that in some form has already entered one of the dimensions, that's always possible. So the unit of measure always can appear as an additional attribute and can be as usable for the ultimate use as necessary. And I hope that that kind of recommendation would survive the test that we will do for seeing whether it works with the multi-measure data models as well. Okay. So in the interest of time, I will stop here and take my other hat and introduce the next presenter. Okay, so our next presenter is Yavuz Çoban, and Yavuz has been working at the OECD for more than 3 years now as a metadata modeler. He has been instrumental in the recent .stat suite migration in the OECD. Assisted many of the organization's data manager to prepare their data models for data dissemination. In parallel, he has provided data modeling advice to several SISCC member institutions. And nowadays, with the migration efforts winding down, he's coordinating acceptance and release testing around the .stat suite application and contributes to new feature definition and performance analysis. And besides providing all sorts of ongoing support for and maintenance for SDMX structures. So, Yavuz, the floor is yours.
Thank you, Yuri, for the introduction. Highly expected and demanded OECD Data Explorer migration is done. There was some controversial about it, but starting from the June to 2024, we switch off the legacy application and auto-forward all the kind of traffic to the new platform. Right now, the OECD Data Explorer is the only corporate data dissemination platform for the OECD. Today, I mean, we just assist so many capacity building activities with the OECD data managers. I don't know how many, but it was really great. And then their knowledge level is very promising right now. After, as I said, completing this migration project, we start to focusing on to kind of a higher level review process to optimize the user's experience in the platform, as well as to understand what we have done so far. Basically, with this presentation, I will try to show just a couple of use cases, and then hopefully we will try to get some insight from you to define our kind of roadmap for the future.
in parallel to the migration project, actually, as already mentioned with the several presentations, we need to harmonize our structural metadata in terms of the code list and then the concepts, because the main motivation for using the OECD Data Explorer platform is to have the harmonized concepts and then the code list, and then reuse these STMX artifacts as much as possible. Try to avoid creating additional custom code lists to get lost by the users. We have almost 60 different concepts and almost more than 60 different code lists managed by our central team. If someone come right now for the new dissemination project, and I mean, we're just basically applying to all the remodeling exercise, but the first idea, they need to go to the repository, our library, and then check to see the existing common concepts and then the dedicated code list. For the reference area, counterpart area, country of birth, and citizenship, these are our common concepts. And in the background for these concepts, we are using the CL area and CL regional code list. For the CL area code list, we just took to ISO 3 and then extended to our internal needs, actually. We're just maintaining one code list, no variation for the ISO 2 or M49. And for the economic activity, we are using the ISIC4 classification. I mean, it's based on the ISIC4 classification, but we just extended with the several NACE aggregation or other needs as well. For the structural maintenance, we set up kind of principles, and for the regular maintenance cycles is actually starting with firstly getting the requests from the OECD data managers, and then it's kind of our team is actually responsible to assist them to kind of bring into discussion, because some of the code lists are actually managed by the domain experts. Actually, and the CL activity code list managed by someone from the trade team, actually, and then the compiling and then dealing with the request is actually their tasks, and we just assist them to smoothly integrate it to the system. If we got any request, and then we announce in the community of practice, and then with the individual moderator, we will discuss in the working groups and then decided to kind of publish the process. But so far, we didn't apply too much the regular maintenance process, but because we are in a fast-track mode for the dissemination, we had a strict deadline from the infrastructure kind of organizational mandate. And we were always using the fast-track mode. For the fast-track mode, we were collecting the urgent requests from the data managers as you mentioned, for the unit of measure code list, CL area code list, and other commonly used code list. And quickly review with the team, and then just put on the community of practice side, and then just make publicly available in the system to continue to the actual dissemination plan. I just would like to briefly describe how the Data Explorer dynamics are working in terms of the discoverability of the data sets, and then I will try to highlight the use case. For the Data Explorer main page, we have in general two options actually to reach the data. Actually, the functional vision in the background is to let me easily find the organization data, actually. We have the first option, like the search results in the background. We are using the Solar indexing. We are indexing the structural metadata, data flows, the related artifacts like dimensions and descriptions, and then the actual labels. Once you make a search, and then in the search facets, and then as a default in the background, Solar calculating one score for each relevant data flow, and then sorting them according to the relevance. This is the first way to reach the data. And in the second way, we have the option to also navigate from the topic list, browse from the topic list. And it's actually in the background centrally managed another category scheme, and then this is also decided by the different bodies in the OECD organization to align with the OECD's the corporate website as well as the dissemination tool. So after selecting the one category, you can navigate from the deeper topic level and then narrow down your selection and then see the relevant data sets actually. I mean, we just mostly focus on the individual kind of migration projects for the different domains, starting from the health, the trade, national accounts, prices, socioeconomic context, and then for the individual projects, it's really hard to see overall picture actually. But after completing the process, we realized that the reference area concept actually for the most of the data sets is a valid concept and then highly used. But for some cases, there's always good reason to deviate from the kind of a standardized concepts and then create variants. And for example, donor recipients for the Development Assistance Committee and Creditor Reporting System, these are very popular data sets for the OECD as a producer. I mean, for the reference area, I mean, in the code list, our code list, we have the actual reference area, geographical reference areas, as well as some aggregation and then the political aggregations. But for the donor and recipients, the situation is a little bit changing because we have that there are some organizations as well as the private funds as well. Representing the data with the reference area will be complicated, so we had to deviate for the donor and recipient, and for the most of the complex trade data flows, we have the exporter and importer concepts to highlight their data sets and represent their data sets. For the, I mean, individual project or individual structures, I mean, these concepts makes sense perfectly, but if you try to kind of collapse them under the same faceted filter, it's going to a little bit complicated. And then let's see the one example. I mean, this is right now available in our production system, and then it's a little bit corner case, not the relevant for all the navigation from the topic list, but for some cases it's a little bit complicated and then really badly affecting the discoverability. I mean, the main objective is to, after selecting the topic list from the top, it's industry and then dynamics and globalization. So the main task is to find all the trade data flows under this data facet for specific country. In that case, it's Netherlands. We have 62 different results. The end users can go one by one and then check the data flows, but it's not an optimized approach, and then we don't like to propose something. But on the left-hand side, you can see the faceted filters, and then these are kind of combination of the dimensions from each structure in the background, actually. So as you can see, it's starting from the reference area, counterpart area. These are, I mean, our common concepts. But if you go a little bit down, the story is a little bit complicating the discoverability. We have the emission origin area, exporting area, final demand area, and then the others. I mean, the main commonality for these concepts in the background, they are using exactly the same code list. Of course, there may be the different versions. But if you select the Netherlands from the first reference area filter, you will see a bunch of data, and then the rest will be disappear. So there's a risk to actually lose the actual data. I mean, that's the one main issue actually for us. And then the second one is the code list variation. From the previous presentation, we discussed the variation like M49, ISO 2, and ISO 3. Luckily, this is not directly from our production system, but just to illustrate the problem. As I said, I mean, we have our structural metadata governance policy, actually. According to this policy, we decided to go with the one code list, one version of the code list, and then the approach is to use the ISO 3 standards. But if someone would like to come with their muscles and then say that, okay, I would like to disseminate my data according to the ISO 2, if you try to type Norway, and then you will see two different results in the reference area in the common concept. If you click the first one, which is ISO 2, you will see 9 data flow. You will narrow the selection according to the ISO 2. But if you do the selection from the ISO 3 codes, and then you will see the much larger data sets. Right now, we will not allow this one, but I'm not exactly sure how this process evolves. And this is just only case for the reference area or geocoding code list, but there might be some other cases for the product or commodity classification, as well as the other variations for the economic activity code list as well. I mean, our conclusion is to whether we are there's a potential risk to kind of create not on the code list silos, but on the concept side. There's a potential risk for creating the silos for the concepts, and I mean, if it goes beyond the 100, then it will be quite complicated to manage. And we were discussing whether business process in the Data Suite platform or OECD Data Explorer will kind of improve the situation, or any kind of solar improvements will help to us, or just on the standard perspective, would it be possible to create an umbrella concept for all geo references in the facets, filtered facets, and then they will not see, the end user will not see any kind of variations, but they will just see the parents, maybe the parent concepts, but once they move to the individual data flow representation, they will see the actual concepts in the model, and then that could be helpful for them as well. And I mean, if that will be the direction, the method, whether we will manage with the concept roles, annotations, or introducing another category scheme, or we will explore the semantic standards, or create a knowledge graphs between these variations in terms of the concepts as well as the code list. These are the main questions, actually, we would like to bring into discussion for the community, and yeah. Thank you so much.
Thank you, Yavuz. I think this presentation has a lot of proximity with the next one, so I propose that we have the next presentation and then we have questions to the two presenters together. So thank you, Yavuz. The next presenter is Matt Nelson. So since 2007, Matt has been heavily involved in SDMX. Most of you know him. Principally designing software solution, including the Fusion Metadata Registry and the Fusion Workbench. In 2010, he joined the SDMX Technical Working Group and was appointed chair in 2023. In this capacity, he is overseeing the release of SDMX 3.1.0, scheduled for the end of 2024, and he is coordinating the work further down the road for SDMX 3.2 and so on. Matt, the floor is yours.
Okay, thank you. Yeah, so for all of you that saw me carry up all my notes, sorry, but we are going to go through every one of these pages. But I will try and be as quick as possible. So the presentation is on, as you can see, unified approach to SDMX interoperability. I've split the presentation into 3 parts, which is part 1 is what do I mean by interoperability, and what do I mean by metadata stovepipes, and how can they come to be. The second part of the presentation, I want to discuss a little bit about the complications that people face with SDMX, and some of these have been already covered by Abdullah, so I'm just going to reinforce the points here. And in the third part, I'm going to introduce a basis for a solution or a possible solution. I myself don't know whether this will even work, but it's something I started thinking about in the last expert group meeting in Mexico. So it's kind of been in the back of my mind. And I thought it's just a good opportunity to present to a group of experts and kind of get some feedback on this. And I can see the confusion. There's 2 green buttons, so I'm going to try the top one. And good. Oh, the big green button. There's only one of those. So there we go. So interoperability. So what do I mean? In the context of this presentation, because we can think about interoperability in different ways, like STMX and DDI. We can say, okay, DDI does all of this, STMX does all of that. We can join in the middle and we can have interoperability. I'm not talking about this. What I'm talking about is something simpler, is interoperability within STMX, right? So you do STMX, somebody else does STMX. Can we make all of these things interoperable? So we're within the same standard, we're using the same syntax, we've got the same REST APIs, everything is standardized. So this should be pretty simple to solve, right? And I'm going to dig into this a bit because the answer is not as simple as you think it should be. So, and I'm going to pick some data structures I'm more familiar with, and actually it shows maybe some extremes. If you like. So let's, and I'm not saying these services exist, this is just a slide for a demo, but let's consider 2 services. And we want to get data for the same domain, so balance of payments. And we pull data from IMF, and we get a really nice, concise set of dimensions, and we get our data. And then we go to, I don't know whether this service exists, but let's say we go to Eurostat and we pull back the same thing. This is the global DSD for balance of payments. So we have a large number of dimensions. And we sit in the middle and we try and kind of join these data sets together. So how do we achieve this? Well, we need a third piece of information. We need a mapping. We need a structure map to say, well, actually, this indicator dimension maps out to these subsets of dimensions, maybe 10 dimensions within the target DSD. And the reference area just maps across, and the frequency maps across, and things like this. But we need this mapping. Without it, a system won't be able to automatically get these data sets into the same shape. So even the same standard, the same syntax, the same APIs, the same domain, 2 different structures, and which is fine because this is what we should expect because people are modeling the data how best suits the community and of their community and how they want to disseminate and collect. So that in itself isn't the problem. So let's get to the problem. Well, let's imagine we are a newcomer to STMX. We decide to use the STMX standard. I just picked smart cities because it's something we could probably all understand what that might be. Where do we start when we're modeling a domain? Well, we start with the concepts, the code lists, and the data structure definitions. And you can imagine smart city data has a strong relationship with geography. So immediately we go, okay, let's find some geography code lists. Let's go to STMX supports geo regions and feature sets and all this really neat stuff that we want to use. You go to find it, and you find that there is nothing for you to use. So you have to create your own code lists, which kind of presents 2 problems. First of all, the barrier to entry, right? Because there's no kind of immediate library that you can just go to and use. That's not the purpose of this presentation. The other thing is people are creating their own code lists out of necessity. And so you have domains which are kind of growing independently from each other, if you like. And where that becomes problematic is coming from the other side. So now you have a data scientist, and I kind of just invented this question, which was very similar to the one used on day 1, I think, which was data scientist wants to know the impact of government policy on emissions data in the UK. And let's say UK, all the smart cities using STMX, and we can go to each API and we can answer that question because it's all standardized, and we have some nice AI layer on top which can pull all the data back. If, however, we expand the question and we say, well, what's the relationship between emissions and respiratory infections and maybe employment status? We can kind of create some kind of question which crosses multiple domains. Now, what we've got here is we've got an interoperability problem, or we probably have one, because it's unlikely all of these domains are going to be using precisely the same concepts and precisely the same code lists. It's unlikely. Maybe they do, and maybe everything's fine, but at the moment, you know, we see what's happening, so we can say it's probably unlikely. And what we've actually done is we've created a data integration problem. So we've actually said, okay, here's the data, you can get it, but you've got to sort it out, right? You've got to do something. And what's really important on this diagram here is the blue lines, because they're the interfaces. And this is where SDMX is really nice, because what sits beneath that blue line you don't care about, right? So you don't care if it's an Oracle database, a MySQL database, or a Hadoop store. SDMX says, no, we've standardized these APIs, so you can ask each API something, you get it back in a standard format. But now you have a data integration problem. So you could imagine that problem could be solved once for everybody, and then we could move the blue line here, so that actually the data scientist does ask a question, they get the answer, data integration's in the middle. So my question then becomes, what is this blue line? And is this AI? Could it be AI? Could AI say, we can sort all of this out for you, don't worry about it, let the domains kind of evolve and we'll sort it out? Or does AI need more to help? And that's kind of what I want to explore in part 3, but now we move to part 2. Okay. I don't know how I'm doing for time, but we'll see. So the complexities. And really, there's only really one slide on the complexities, and it's all challenges start with a code list, because every complicated problem I've ever, you know, the most complicated problems are basically the code list related, which is really strange because the code list is probably the simplest artifact in SDMX. So it's like, oh, it's brilliant. Everyone understands what it is. It's a list of codes. You have ID and label, but yet it creates these challenges. So I'm going to go through these one by one. First problem, what's included in the code list? So actually, as mentioned earlier, CLSEX, I can't remember how many variants you said you had of the code list, but there's 3 versions in the global registry belonging to SDMX, and there's 2 belonging to UN or the SDGs. And I look at the code list, and the content changes depending on the version, right, the number of members. And I read on version 2.1 this description, which is it applies not only to human beings, but to other living organisms, which of course is excellent unless you're a snail, because snails are both male and female at the same time, and there's no code to cover that other than the code other. So, and this was an example actually of my first encounter with the complexities of code lists, because it was at the FAO, and it was a very similar comment, because they said, why are there so few cross-domain concepts available to use, but so many cross-domain code lists to use, but so many concepts are available? And this was kind of back in 2009, so there really were not very many cross-domain code lists at all available, but one of them was the SEX code list. And we said, well, you know, SDMX, it's really hard to agree upon the content of the code list at a kind of global level, so there's not so many, but CLSEX is one, we have male and female, and they said, that won't work for us, because we have fish, which change during the lifetime of the fish between. And it kind of like demonstrates that how can you solve a problem on the content of a code list when we can't even do it for the smaller code lists? You know, as soon as you start to get to like larger code lists, it becomes very, very complicated. So we look at things like the country code list. Well, actually, I couldn't find the ISO country code lists in the global registry, the ISO standardized ones, but I think they've been bundled into CL area. So we find sort of like a number of country code lists, and they have like different groupings, and not only countries, but it's areas, right? So we have international organizations in these code lists, like OECD and IMF and things like this. So that brings me to the second bullet, which is which code list is the master code list. Well, like I said, in the global registry, I'm looking and I see CL area. I see quite a few CL area code lists. I go to web services of agencies for their own variants, and I see another, say, free code list from the BIS. There's CL area, there's BIS IF ref area, and GL ref area. There'll be others from the OECD, I imagine, and IMF, and many other people. So many variants of basically the same thing. And even when I look at that thing, CL area contains a code for Denmark, Norway, Sweden as a single entity. And so different breakdowns within that code list. So if you're a newcomer to SDMX, where do you start, right? Which code list do I use? Which one? And even if I find the one that I want to use, because it contains all the codes that I want, and then I go, well, actually, I need these codes in Thai or in Portuguese or in some other language, you can't extend them to add a locale. You have to duplicate it and put your language in. You know, you can extend code lists to add codes, but not to augment existing codes with more information. You have to duplicate. So what we end up with is a mapping issue. We end up with a mapping issue, and we see this with AI, with the World Bank's, I think it was World Bank, no, it was the UN with Google Data Commons. It becomes a mapping issue to map to the entities of Data Commons. But they first have to consolidate all their country code lists into one in order to then map on. So we end up with a mapping issue. The next problem, I will get to the end of the problems soon. I think this is the hardest problem. I don't know whether it even has a solution. What does it even mean? So you have a code, you have a label, but the meaning changes based on context. And I think Abdullah's come out with a few examples. One during this presentation, but one previously. I think it was access to drinking water, and you know, you collect data from one country, and their definition of access to drinking water was within the boundaries of the residence of the household. And maybe another country, it's within 100 meters of the residence of the household. So even if you've got data which is classified the same way with the same label, doesn't mean that data is going to be comparable because of the way it's been collected. Now, what I'm going to propose, the solution, I don't think really solves that problem. And I'm not sure it's even a solvable problem, other than to know that there is a difference, so that when you are trying to combine data, you know there's a difference, and you can look at what that difference is, but I don't think we can eliminate the problem. It's not an SDMX problem, it's a problem with meaning. Number 4, when is a code not a code? Well, when it's a concept, right, or an organization. Unit of measure, which someone mentioned it earlier, it's like, have you considered having it as a measure rather than an attribute? Well, in order to have unit of measure as a measure, it has to be a concept, right? Because a measure dimension is pointing at concepts like USD and whatever. Or it could be a code in the code list. You could have like births, deaths, marriages as measures. They have to be concepts. They could be in the code list called life event, then they're codes. You could have an agency, IMF, as an agency, but it can be in the CL organization code list, and it can be in the reference area code list. So I find myself in FMR, like writing metadata, thinking I've done this a million times before. You know, I'm writing IMF, International Monetary Fund. I'm translating it into different languages. And then you go, well, that's that in a code list, but now I've got to do the same for an agency. And I've got to do it again for a data provider. And I've got to do it again in the CL. You know, so where are we going to put our translations? Where's the master information? And also, you can't map between these things. You can't map between the concept and the code and the data provider. You can't even say they're the same thing. So it has to be kind of implicitly known because they have the same ID. And the last point is demonstrated better by a slide, I think, which is to do with composites of information. And again, this isn't an issue because people will, of course, have codes which combine different concepts. Because, you know, if you collapse a code list, or sorry, if you collapse, say, 5 or 6 code lists into an indicator code list, that has benefits, you know, for data visualization and dissemination. But what you've what you're doing is you're losing information because you've lost the concept. So there's 112,000 possible codes here. What if I want all the codes to do with manufacture of refined petroleum products? Do I, if I'm selecting these, I have to tick them one by one. But what if I just want to say, I just want those codes and bring them all back? We've kind of lost the underlying concepts. But each one of these codes is backed by a number of concepts. So when I come to the entity model, I'll show you how this could work with an entity model. That ends part 2. So a quick summary. SDMX basically packages things into boxes, which can create problems because we have to agree on the content of the box, what goes in it. Number 2, in order to create interoperability, we need to create relationships between these things. So we have a mapping problem and we have a box problem. So the last part kind of tries to address these problems. And it's just an idea that I'm thinking about. And I'm not even saying this needs to be done in SDMX, because maybe something already does this that we can leverage. And maybe people in the audience can come up with ideas at the end. But basically, let's get rid of the box, number 1. And let's create a foundational layer that sits beneath SDMX, which SDMX can leverage. And by that, I mean the following. I don't know how easily you can see this. But the idea is there is only really one object type. And I wanted to call it a concept, but concept's taken. So I called it entity. But it's basically, everything is an entity. So United States, Australia, country, political union, state, Florida, they're all just entities that we can create. And an entity is just a label and a global unique ID. The label we need so we know what it is, but we don't want to necessarily multilingualize it at this point. Just a label and an ID. And then there's another object which sits between the entities, which creates relationships. So you could say, well, actually, United Kingdom is a member of country, and it's also a member of NATO, and it's a member of the UN, and it's a member of the European Union, which is which is true for a point in time, right? So the relationship has a temporal validity associated with it. So what this allows us to do is, because things change over time, right? We can actually say, give me all the entities that are a member of the European Union at this point in time. And we end up with a set of entities. And we say, give me all the entities that are a member of the European Union at that point in time. We end up with a different set of entities. But we can easily create sets from a kind of entity and relationship model. And what this allows us to do is define kind of either implicit sets, like anything that's a member of a country. We could create intersection sets, like it's a member of the UK and it's a member of a town, and then we get the UK towns. And we can create composite sets. So it's a country and it's an international organization, and maybe that's our ref area set. These are not code lists. These are just sets of entities for which we want to use for some purpose. Countries excluding USA is a set with an exclusion rule. We could even think about an entity as being a combination of other entities. So we could say we're going to take USD and base period, and we're going to say that's a member of a unit. So then that becomes a unit where the entity is backed by two other entities. I think, Abdullah, your example earlier, which was infant mortality rate. So you could actually have this thing, but say it's backed by 3 entities, and therefore you can still use that code, but people kind of know what underpins it. Where the code lists come in, because actually largely we don't care about data collection. I mean, you care that you're collecting data for a country, right? But there are so many variations of identifier that in a way it's like, well, you just want the data for the countries. And Whether somebody wants to export that from your system in ISO 2, ISO 3, or ISO numeric is kind of, in some ways, not irrelevant, but it should just be, well, this is the base entity that we are linking to, and we're saying that can be represented this way, or that way. The code list actually just becomes an ID mapping to an entity. And but in this model, I didn't want to sort of like, I wanted it to sort of like allow people to design the code list the way they currently do with SDMX, so we don't throwing everything out, but have that option to say, I'm only going to provide an ID and a link. Because once I've linked to that entity, that offers all this extra information. Because what else can you link to entities? Well, you could link multilingual labels, you could link different geography representations of this thing over time. So I could say I want the boundaries for the United Kingdom from 1860 or whatever, and so I can kind of move through time without having to bake that into my code list. And this allows people to use whatever code list sizes and shapes that they want, but they point back to the same entity, which means we can easily move through the model. I think I'm getting very close to the end, actually. Yeah, so what are the benefits? Well, I don't have to fill in a name and description every single time I create something. I can just point to a base entity. I can find other kind of locales because they can be kind of augmented over time. I could be able to find geographic information that points to the entity, but I don't need to kind of bake that into my code list or my model. And be able to know other relationships as well, which is really important. I can say, well, I want data for NATO. And there may not be data for NATO, but it knows NATO is made up of this set of entities. And that allows me to kind of move between different models because it's like, well, they've collected it at this aggregate level and they've done it here, and I can kind of move between the models. And oh yes, finally, again, this is just a kind of an idea really, which is some entities are going to be abstract. I mean, age range is an example, right? I think where it kind of contains a numeric value behind it, but it's coded. But you could have codes like hot, cold, and tepid. What does that mean? Well, it depends on the context of the data collection. If you're collecting data about sea temperature, hot would mean something different to data about the stars in the universe, where hot would have a completely different range. And then behind the entities, you could theoretically kind of have numeric kind of things underpinning it, if you like. And I'm going to leave it there. I'm not saying I've solved any problems because my thought process kind of stopped here, and I was like, I'm done with thinking about this. It's more now a question I think for everybody to start thinking about is, would this work, or can something like AI just say, well, you don't need to do all of that because AI would do it for you. So you're just going to waste your time trying to do this. And that's where I leave the presentation.
Okay, thanks, Matt. I would like to invite all the speakers in this session to maybe come and sit, and I will take questions for the whole session, but of course, if you have immediate questions for Matt, you can start with that. So I see Edgardo. Let's give a second until.
Excellent proposal that, of course, requires more discussion. But just a couple of comments just to see if I am on the right understanding. First of all, this issue of the different meanings that a code is or an item can take, I think that this, I don't see that as a problem. I think that this is an advantage because a code list is meaningless, and this allows you to share a code list across different concepts. And then when you associate a code list with as enumeration for a concept is where it takes different meanings because they are different concepts. So if you put meaning in the code list, that means that you cannot share. So you should have to balance what is better.
Yeah, no, I agree. I mean, I didn't have a slide on it, but I would see the meaning as being a layer above, right? So that's in the context layer. So the underlying entity should be kind of almost void of the contextual meaning, if you like. But systems which are trying to create that interoperability should know that we can't really combine these numbers precisely. However, we can at least let people know that there's nuances behind these.
But this is where I was going to. The semantic interoperability should be done at the level of concepts and not at the level of code lists.
Okay.
Because in SDMX, code lists are semantically agnostic.
Yeah.
So, and the other point regarding the issues with the global registry, I think that we have a problem with the global registry that so far it has been used not really as a source of truth, that is what you're thinking of, but mostly as a share folder for relevant artifacts to be shared by the community. And this is also something that I hope will change with the global discovery services, because each agency will be able to host their own artifacts in their own registry and still be discoverable.
I think what we've got, though, is we can share as much metadata as we choose, right? Let's say everybody shares their metadata. How many duplications are there going to be? There's going to be so many variants of France and different code lists and things like this. So I think it's great to have that capability, but if people could underpin their codes with an entity, so it's like, then we know we can start to sort of like reuse that metadata, but move between systems that might use a different code list for what is essentially the same thing.
Okay, Daniel.
Yeah, my question goes to Yavuz. From the challenges that you were presenting at the end, I was trying to understand if we are talking now about a problem that STMX can solve or a problem that the Data Explorer or the tools need to solve. Because from the challenges I saw, most of the things in STMX you could model, but then the question is, how do you present? So for instance, these geo-references you had, okay, you have like 5 or 6 different concepts that represent somewhat geo, but they are different filters, but at the end of the day, we have the concept role, and maybe you can collapse them in the interface. Or for instance, you have code maps between the ISO 2 Norway and the ISO 3 Norway, and you could collapse them in the interface by reading the metadata. But maybe I did not see, that where the problem comes. So it was more like, is there a problem in STMX we need to look at, or is there a problem in parsing the metadata or managing the metadata in a way that the interface could present it to the user in a more digestible way?
Yeah, thanks a lot for the question. I think, the main problem comes both sides, actually. There's some kind of missing on the business level, some missing aggregations or smart features on the business level, and as well as on the STMX level, maybe. I mean, just to gather the ideas from the external standards as well. The concept role can work, even if you can create a hierarchy for these related concepts, and we can force the system to say that, okay, just represent the parent concept, and then the rest will be hidden or expressed in some system. But I'm not sure whether this will solve exactly the problem. Maybe it can work for the specific domain, but for the others, for the code list variations, I'm not really sure whether this will fully solve the problem, because it's a little bit different. In the first case, it's purely related with the concepts and then the existing concepts. But in the second case, it's also touching the individual code list in the shared library as well.
Yeah, thanks. I was more referring then to use structure maps for using them to collapse the things. So concept maps or code maps, and then concept roles in order to say this is all geo, and there's a concept map, they're related, we collapse them in the interface. But okay, it's to play with it, right? What works, what doesn't. Thank you.
Thanks for all of the presentations. So my question is for Matt. Yeah, I mean, really interesting proposal, Matt. With the entities, it's like, it's like a really useful level of abstraction, which almost like removes some abstraction, because I guess entity is closer to the real world. But I just wonder how the maintenance would work, with such a model. I mean, so who would actually maintain the entities, and would you almost need a maintenance of the relationships, right? So like the IMF entity. I mean, would it be the IMF who would be the maintainer of such an entity, or I don't know. It's like, would that always be the case, or like if the IMF somehow didn't need an IMF entity, but somebody had to invent one, then who would be the maintainer, and how would you control the kind of relationship? So yeah, thanks.
Yeah, thanks for the question. It reminded me of a question, actually, I think it was in The New Scientist, where they asked the people that wrote Star Trek, how do the inertial dampeners work? And they said, very well, thank you. So to answer your question, I don't have an answer to your question. I'm providing a kind of basis for onward thinking. It gets complicated because, even people that I've spoken to are saying, well, we're never going to agree on the graph, for example. The idea behind this was, it's not necessarily like a free-for-all, but it's kind of gives power to sort of like groups to create entities in the domain and create the relationships. And if you don't agree with those relationships because you want to use something else, it's somehow built in to overlay your own. But really, I don't have the answers. This is kind of as far as I got.
I just have a point really related to this, because when you showed the entity diagram, those of you who may be familiar with semantic web standards and linked open data, and especially the SCOS standard, which stands for Simple Knowledge Organization System, probably as soon as you saw the diagram, you thought this looks a lot like SCOS, because you have an entity that links to another entity via a property. An entity becomes to some sort of a class, and the property could be conceptualized as having also a class. And we have been working in Eurostat with linked open data and the SCOS system, and indeed it allows you this great flexibility of linking entities to each other and to whatever. But there is obviously the difficulty of saying, okay, well, who decides on what to link with what? And SDMX is a closed model. You can only do, at least so far, right? It's a closed model. You can only do what the model allows you to do. You have an object called entity. You will be able to give it properties that are allowed for the entity object. And the way this was solved with linked open data is that also the model is open. There's no prescription. You can have an entity, a URI, and I have my properties. I associate it to my properties, and someone else conceptualizes the world differently, and he adds his own properties. There's no limit or prescription onto what you can apply, which means that every user can define his own entity model and his own relationships based on the same objects. And I don't know. I think that this is a question to consider, because can we really have? Can we have an entity model in a closed system that implies some sort of agreement in a way on how the relationship should be mapped? Because in the linked open data world, you have this entity model, which is very granular, but there is no idea that there should be an agreement on how this should be mapped. It's very open. And so I don't have, it's not even a question, it's just a remark. And I just had also a point, maybe, or a question to your, at the end, or at the beginning even, you said, is it going to be solved by AI or by this kind of model? I would say maybe both. I think I would have trouble thinking that I can assume that the modelers will be so good at modeling the entities in a way that really machines will be able to drive processes consistently using these models, because this member of each person will conceptualize it a bit differently and do mappings a bit differently with a slightly different semantic meaning maybe. So I'm not sure that we'll be able to, if we go in this direction, to have modelers really apply these definitions in such a consistent manner that you can really have tools predictably based on them. But AI could use this, right? AI could know in a bit fuzzier fashion, okay, this thing is somehow related to this other thing because someone told me it is, and then I can use this to inform whatever I give back. So to me, the answer could be, it's not an either or, it would be an and in that case of whether AI or this model would solve this. That's it.
Yeah, thanks. I think just to come back on that, I mean, one option, of course, is to have an authority to create the relationships, but people could create their own relationships, right? And then you have different kind of schemes of relationships. Tom said something a while ago, which is someone he knew that built some buildings, and they're like, when are you going to put the sidewalks in? And they said, well, we're not. We're just going to let people walk on the paths, and then that will tell us where to build the sidewalks. And in a way, that it could be that you create a model which is very flexible and gives people options, but actually what gets born out of it is the most commonly, we're using this variant of this hierarchy, which gives us our sets very, very neatly. Yeah, somebody else over here did something, but that's for his own purposes, and we don't care too much about it. So it could be something like that, but these are kind of critical questions to think about.
Just adding maybe another point to this discussion. So this approach, I think, exists on the kind of limited scale. So there are ontologies, even for statistical purposes. So I think the Italian Statistical Office published ontology for, I don't know, census data. So on the kind of domain level, it exists. And I think as long as you have the community agreeing upon them, they can be extremely useful, because then you can use knowledge graphs and stuff like that and have this alternative way to search. In CBS, we tried that approach on a more general level, I think 5 years ago. Again, it is possible. It was possible in theory. We had like a proof of the concept on our data dissemination database that provided some semantic search, but the problem is what you mentioned at the beginning, that the reality. So how do you build this thing? Because even if you don't go across different organizations, like even if you stay within one statistical organization, you have so many concepts, so many things that you would need to have some sort of modeling authority to make this big model and then maintain it, and that is at the moment, I mean, at the time it was very difficult. But when you have it, it can be very powerful.
Yeah, from a kind of like initial level, every entity is just an atomic unit of truth, right? So it's like France, Germany, Spain. These exist. We're not disagreeing that these things exist. But at least that gives a point to tether metadata to underpin it. And that gives that capability to move between models. Now, if you want to combine France, Germany, and Denmark and give it a code, that's fine. But you're underpinning that with three entities, which we agree exist. So you could start simply with countries or with things that are not, that are just atomic units of thought, essentially. And that's the entity library, which then you can augment with different languages and representations. You can attach geographies to it. Now you've got a really nice base of metadata, which somebody starting on STMX can go, this is great. I can actually create my own code list because I need different breakdowns, but I'm going to underpin them by this. But we don't need to start big. It could be limited in scope.
Do we have other questions from the floor? Or? Yeah, while we have one here first. Edgardo already had his question.
So maybe a comment and a concern. So my concern is, we've heard throughout this time that, it can be difficult for people to get into STMX and, perceived complexity. Well, I think this would be maybe a little bit more than perceived complexity. And, what Abdullah, because like what Abdullah was saying, like these M49 people who want to touch STMX as little as possible, I wonder how this sort of idea would work with something like that, where they're really handling all this modeling outside of STMX, and they just need to push it to STMX. So that's sort of one comment. And my other comment would be, I wonder if some of your pain points could just be solved by slight modifications to the standard. For example, being able to point a concept at not a code list, but a term in a code list, so that I can use that term, the information attached to that term, for a measure. I just wonder if there's maybe like baby steps you could take to solve some of your problems.
Actually, what I've been thinking about was, it's not so much about perceived complexity of SDMX. I think that it's more about the actual complexity of data. And what I want to call on everyone, starting with myself, is to explain to our managers just how complex the data is. And it's very difficult to do that. Because once you try, or because people don't want to hear, especially managers, they don't want to hear that something is complex and expensive. They want to hear that someone steps up and says, I'm going to do it, and I'm going to do it quickly. And then they do it, and then, 5 years down the road, turns out that that system is not maintainable anymore because it was badly designed from the start. To do things properly with data, it's very complex, it's hugely expensive. In terms of M49 and in terms of people, we can agree what France and the UK are. No, we can't. Because at the UN Statistics Division, there are at least three, probably four definitions of the United States. There's the United States including Puerto Rico, United States including Puerto Rico and Virgin Islands, and the United States including Puerto Rico, Virgin Islands, and minor outlying islands. Why? It matters a lot in trade because they are all different custom zones. You fly from the US Virgin Islands into mainland United States, you have to fill in a customs declaration. The question I'm asking myself, it's not even about SDMX, it's a fundamental question about data. How much effort are we prepared to spend documenting our data to the point that it's as unambiguous as possible? I don't know the answer. But I also think that if you aren't precise enough with your data, you can get very dangerous and very misleading conclusions, which is why I think that maybe, I'm not convinced that this layer, an additional semantic layer, needs to be part of SDMX. Maybe yes, maybe XCOS is more appropriate. I just don't know. Maybe something else. But that it's needed, I think it's, is obvious. What is a question to me is just, are we prepared to spend this effort on its maintenance? And is there anything that can be done to reduce that effort?
I think it was Janusz that explained that at the OECD now you are using a single concept scheme and maintaining that. So have you been able to avoid any local representation in all DSDs so that information is taken from this shared concept scheme, or are you including the same code list in all DSDs?
Yeah, for the reference area concept and related concepts, that's not the case. I mean, we just stick to our existing CLRA code list, but just one variation, but it's already derived from the CLRA code list. For the CL regional, we have some regional statistics. We just took existing ISO 3 CLRA, our master code list, and extended with the regional code list. That's the only case, but for others, we always force data managers to use the common CLRA code list.
I'm not talking about CLRA only. I'm talking about data governance concept in general. If you manage, because for me it's a dream situation that you can have a single concept scheme, a single set of code list, and nobody else can use any other. But the standard is flexible and allows you to use the local representation in any DSD so that you can have a copy of the code list for each DSD.
Not directly copy of, but some code lists, for example, COICOP code list, we have the 99 version and 2018 classification for some dissemination purposes. For the national account case, they are using the local representation in the concept scheme, everything is the same, but for one single DSD, they are using the latest version of the COICOP classification because they have the mandate to disseminate their figures, the expenditure figures in both classifications. That will be the case for others as well, but in the future we will see actually. If someone in the future would like to disseminate data with the two different versions of the ISCET classification or ISCO classification, these are, I mean, mainly OECD-based ones, and then we will try to apply the same principle actually for these ones.
Thank you, everyone. I think in the interest to getting to our lunch in time, I will close the session 3 minutes early. Thank you all. Let's have a round of applause to our speakers.
So off to lunch in the usual place. Please be back at 2:30 for the last common session of the day. Thanks.